Okay, we exactly chosen for the second chapter. Exactly in second chapter, we have chosen AW channel, how it is really affecting, how it is really affecting the signal is flowing from transmitter to receiver. As we mentioned, AWG channel, additive wide Gaussian channel, which is additive wide channel, which have a noise constant throughout the channel, and that is independent of the frequency, which means that whenever the signal is, whatever the transmission message is absolutely here, the signal, whatever the signal will not get corrupted as a signal is flowing, but some kind of a noise get added because it's a noise is constant AWG channel. And we also mentioned in the second chapter, what are the factors we likely to be taken into effect, how the signal will be transmitted. For example, the signal will be coded in the form of S1 of 2, S2 of 2, and each S1 of 2, each S1, S2, S3 will be quoted with what exactly bias function, which is absolutely transferred along with that channel, and the receiver will observe that movement. Then it will identify whether the received is correct or not with the help of the probability density function by using a statistical analysis whether the receiver is correct or not. So how exactly, what are the kind of the process takes place to the receiver? We have mentioned it. As soon as the information received from the transmitter via channel to the receiver, which is exactly called as input, which is exactly called as input, that we call it as an observation. Then each observation, the observation element, that is observation element, that capital X of 1, capital X of 2, each will be analysis to a random nature, random variable, because the noise over the channel will randomly changes because due to external and internal factors which we have mentioned very clearly in the preceding chapters. So once the channel, that means whatever the observed will be, whatever the observed vector, that is the received input at the receiver, will be analyzed with the help of the what exactly, with the probability density function, with the help of the random natures. Let's not, this is absolutely, this is what we have studied in the chapter number 2. Now let's come back to modulo 3, and that is exactly unit 3. It is the one, that's the unit which talks about digital modulation techniques. Please mention, I have clearly mentioned it, and you know, and in our preceding semester, in the previous semester, while studying analog communication, whatever the signal you likely to be sent from the transmitter to the receiver, this will be protected within the some form of the signal. What we exactly we're changing, whatever the signal, okay, exactly the signal flowing from transmitter to the receiver, okay, which is absolutely we're going to protect it with the process called as the modulation techniques. We have the modulation, number 1, amplitude modulation and angle modulation. From the angle modulation, we have frequency and also phase modulations. The signal will be protected with the help of some carrier by using the techniques of carrier, unmodulated carrier. That carrier wave will be used for protecting the information signal, what we call the information signal, what we call it as the baseband signal. This baseband signal will absolutely flowing from transmitter to this baseband signal, along with this carrier, what we call modulated signal, will absolutely flow across the channel, and it receives by the receiver, and the receiver will in turn absolutely checks, absolutely of the checks the receiver, the modulation techniques, modulation received signal, and it interference, and it exactly at interference that or interference or analyze or retrieve back the original information through techniques called as what we call it as a demodulation techniques. We have demodulators, kind of a demod, which is generally is the opposite nature of the modulator, which were used in transmitter for modulating the baseband signal. Please mind it, baseband signals are the information signal. Whether this term is common for both analog communication and digital communication. In the similar manner, digital communication, we are going to, even though digital communication, we are going to send the information, the binary form, that is a set of binary forms, binary symbol 1 and 0. Even that binary signal, we are going to convert into electrical pulses like on and off, okay, on and off. So in so many forms like NR set, polar set, and non-polar set, and we have a lot of how we are going to send. We are studying the line coding in this first chapters. So whatever the information, that is, let us say the information, we have a set of binary symbol 100001 like that, okay, exactly. That set of information signals will be converted into the electrical pulses at the, what do you call it, sir, more digital modulator in the transmit of digital communication before we sending via channels. Okay, so this electrical pulses, okay, exactly, will be sent across to this. Please mind it. This, if you said generally, these electrical pulses, that is the information form which contain the information, then definitely the signal will get corrupted or distorted due to so many external and internal factors. So for which what we are going to do, we are protecting this electrical signals, electrical binary sequence pulses. Okay, we protect this binary sequence pulses by using unmodulated carrier wave, that is analog, definitely analog signal like a cos omega ct or sin omega ct. We are going to put this binary sequence into this carrier through what we call it as modulation process, as same as the analog communication, and we send it across to this. Please mind it, we are across the channel. Please mind it very clear. Whatever the electrical pulses you are going to send to the modulation process, again, it is in analog form. That's a lovely, okay. We are, as we all know, yes, definitely we mentioned it, the binary sequence 11011 in an information, which we converted into what? Electrical pulses after the channel decoding and channel decoding, binary decoding, exactly. Let us forget at this stage. So whatever your stages you perform at the modulator, that electrical pulses of the digital communication, then automatically we are doing with the modulation techniques with the help of analog signals. That analog signal, that means we can certainly say whatever the information of the binary sequence will convert into analog signal, that is the one in a digital modulation techniques. Of course, at the end, we are going to retrieve that information in a digital form only. That means whatever the information, analog signal, which is contained the information of the, binary sequence in the form of maybe amplitude or in the form of the angle, that is a phase or a frequency of the signal of the analog which are used as a carrier wave, will retrieve back that. That is exactly digital modulation techniques. Please mind it, what is exactly digital modulation techniques? Whatever the electric pulses at the demodulated techniques, digital modulated techniques is the last block of the transmit of the digital communication from which we are going to send that information via channel media. Before sending that channel media, what we are going to do, we protect this binary sequence with the help of the unmodulated carrier wave, like cos wave or cosine wave. We put this binary sequence in this cosine and sine wave in order to protect, our binary signal, to avoid distortion or corruption, chances likely to be occur while flowing in the channel from source to the destination, that is a receiver. That means in this kind of a process, we call it as digital modulation techniques. Please mind it very clearly is that even though our information is a binary, which we are converted to the binary sequence pulses in any form, whatever we like it, but this binary sequence of pulses will be put it across to the analog signals, and it will be sent across the channel and it receives. That means whatever the information, that binary sequence, will put inside the unmodulated carrier wave and it will be reached. This is exactly demodulation techniques. Okay. See, please mind, one more very important advantage of digital modulation techniques is the one, apart from protecting the signal, and that is we are protecting the binary sequence in that unmodulated carrier wave. Okay. Apart from that, second most important, this modulation techniques will help you to send the signal in high frequency signals. For example, when you send the information, for example, if I just send it up, let us assume that in binary pulses, binary sequence pulses, that is 10001, whatever the information, when you are going to send that information over the channel, it is possibly only for a low frequency. There is a chance in that also the signal likely to be corrupt and distorted. That means that when you protect the signal inside the carrier wave through the modulation process, we can also transfer that modulated signal which contain our information with high frequency. These are the great two advantages of the modulation. One is protecting the information. The second is sending the signal, that is the information signal, okay, in a high frequency, which is most important as today electronics demands of high data rate applications, high data rate. It means that high frequency signal. That means you are going to send the signal with high frequency signals. What today revolution of electronics is going to see. That is why the modulation techniques plays a lot of vital role as on today communication department, as on today's electronics. Without communication, it cannot achieve anything today in electronic device. Please mind it. So that means I can certainly say the modulation techniques will help you in our digital modulation. The two factors. First factor will help you about what you call it as the protecting the information while flowing from transfer to the receiver in such a way that it cannot get corrupted or distorted. Second point is that absolutely it will also help to transfer our message in a high frequency manner, which will help you to pass the signal at high speed, and with also application to the high data rate information, and it will help us in today's data demand. So with this aspect, with this keeping minding of two factors, the digital modulation techniques, I'm just going to what are the kind of a modulation techniques absolutely used in a digital modulation techniques. That is the signal which is modulated, that is a baseband signal, that is the information signal modulated by, modulated by unwanted carrier waves in a digital modulator. At the transmitter, there are three types. So far used is number one, modulated shift key ASK. I hope you got my this is you are getting exactly. Look back in the digital communication, three basic type of modulation schemes are used in order to modulate the baseband digital signal. The first is exactly amplitude shift K. The second is phase shift K. Third is frequency shift K. See, these are the techniques. Of course, this is the techniques you are using. Where exactly, let's, for a moment, we can remember back the analog communication we are going to use. We are going to use amplitude modulation. Second is what exactly? Phase modulation. And thirdly, frequency modulation. Here also, the same type of has been utilized, but the different phenomena has been given here because depending upon criteria, principles used in transmit the binary signals. That is a binary pulse. So same principle. That is, please mind it, analog communication, amplitude modulation, how? The unwanted carrier, the unwanted carrier, that is a carrier wave we call it as, is varied according to the amplitude of the baseband, that is the information signal we call it as amplitude modulation. The frequency of the unwanted carrier, that is modulating this to be modulated carrier, that is sin omega c, will be varied in accordance to the frequency of the signal, frequency of the baseband signal, which we call it as a frequency modulation. In cases, if you vary the phases of the, if you vary the phases of the signal in accordance with the phases of the carrier wave, in accordance with the phases of the signal that is to be transferred, we call it as phase modulation. In a similar manner, here also, the digital communication, we use amplitude modulation. We use amplitude modulation called as amplitude shift key, and frequency modulation we call it as frequency shift key, that is FSK. And thirdly, if you vary the phase of the signal, if you vary the phase of signal, that is a baseband, in vary as of the carrier wave, in varies in accordance with the baseband signal, the information we call it as phase. Here we call it as phase shift keys. That means you understand. Now digital modulation techniques number one, very important point is, first point is very too important. Why we are doing digital modulation? First point is to protect the signal in order to avoid the corruption of, or getting distorted while flowing from source to the destination, that is transmitted to the receiver part. Secondly, it will also help for transmitting a signal with a high frequency, which is as for today's demand of electronics or all the kind. So with that, there are three types, with the three type of digital communication, digital schemes used, modulation scheme has been used in the digital communication as analogy with respect to the analog communication, which we have called as amplitude shift key, that is ASK. Second is exactly, we call it as a phase shift key, PSK. Third is frequency shift, as called as what exactly, FSK. Now let's go. Let us simple. See this amplitude shift key. Okay, amplitude shift key we call it as. Okay, exactly. Amplitude shift key we can call it as. Look back here. Okay, exactly. Amplitude shift key. Let us look back. I don't want a very good notes has been prepared for you people. Let me give it. So look back here. Amplitude shift key. This is the, let us say this is the information signal. 1 0 1 0. Okay, exactly. Look back here. This is the, let us say this is the data to be transmitted 100110001. This is data to be transmitted, and when you come back, this is the carrier wave which we are going to do modulation of this is the baseband modulation of this signal. That means we are going to put this 10001 into this. Look back, this is, we use this on-off signaling method. That is exactly, we call it as on-off signal NRZ. That is non-written zero, one of the line code, which is, that is we have studied. So this, the information 1011001 information to be sent has been coded on-off key, okay, or a non-polar written zeros, which we are going to put this into this carrier wave, okay, through a modulation techniques, what we call it ASK. What exactly ASK? Look back here. The amplitude of this binary pulses to be transmitted, one, wherever the one, okay, we'll pass this carrier waves. Look back here. We pass this carrier waves here. In a similar manner, okay, wherever the one, we pass this carrier wave, wherever zero, there is no passing of the carrier wave. I hope you got my point. One is there, this particular signal I am going to transfer. One is there, I'm going to pass this particular transfer of the carrier wave. Where zero, no signal of the carrier wave will be passed, and such kind of a signal we call as an amplitude shift frequency. It's also analogy with respect to what amplitude modulations as of analog communication. What we are going to do here, we are shifting. Look back. Why we call it an amplitude shift key? Because we shift the amplitude. Okay, shift the amplitude of one in accordance. Shift the amplitude of the carrier wave in accordance with the what? The binary to be sent, which is exactly called as binary, okay, exactly, binary signals, and we shift this amplitude according to which, because we're cutting across this, and hence we call it as ASK signal. See, this type of a modulation is also called as on-off keying over, since the carrier wave is passed during the on position of the corresponding to the baseband signal. I hope you call in ASK what you are going to send. We are going to send absolutely the binary signal. Okay, the amplitude of the carrier wave will be sent only where there is a one, and other things is exactly zeros. Will be where there is a zero of the binary signal. We are not sending any kind of the carrier wave. That is, we are shifting this amplitude in accordance to the amplitude of the binary. We call it as amplitude shift K modulation, which is same as your amplitude modulation. So this is also called as on-off keying OOK. Okay. Secondly, what will happen here? So this, see, look back, we are going to use the spectral density of the ASK is simple. Why is the spectral density of the ASK signal is, see, this is use the carrier. That means whatever the information that is 110, what we have shown in the last, what we have taken in the example, which will be put across to the where the carrier wave. This carrier wave will be consist only one at the output. At the output, we have the wherever the binary pulses are one, and remaining of the carrier wave is zero because the binary sequence is also zero. So that means this information will put into one carrier frequency, that is unmodulated carrier. That is why the specters, the information will absolutely in and around of this plus or minus of the omega c, and the spectral density of the ASK has been given as this form. Look back. It is a cluster around plus and minus of this. And the power spectral density, what exactly? It indicates the power. The power of the signal is indicated the energy. Energy will indicate the information. And the power spectral density is so important for the conveying the information at the receiver. Okay. So next, let us take the second one, phase shift key. What exactly the phase shift key here? Look back. Let us say this is the information in 110001. Okay. Look back here. 100. What I am going to do in this kind of a FSK, if there is a one pulses in the binary, I am going to send PT. That is, PT is this information. Cos omega CT is equal to what exactly? That is the carrier wave unmodulator. For sending one pulses, I am multiplying 1 into cos omega CT. For sending the zero, okay, the first for sending the zero, I am multiplying this what exactly? Minus pt into cos omega ct, okay, minus I can write p of t into cos omega t please. But that means that one and look back, one pulse will be p to cos omega ct, zero pulse will be sent with analog signal of pt cos omega ct plus. That there is a difference between these two is what exactly? 180-degree shift. Okay, exactly. With this 180 degree, look back how this is a PSK signal final. Look back, this is the up to this, there is a one carrier frequency start from this point to this. When it started with the zero, look back here, this absolutely zero, the phase of this has been changed, clearly indicating phase of this card. And similarly, when the zero is transferred, when you come back to what exactly? From the zero, once it goes starting from one, again phases has been changed, and it is common factor of this. Since at this point zero changes, the phases of the carrier signal is also changed, which is clearly indicating all these things. This at this point one and comes. See the phases, that means in this phase shift key, depending upon the pulses, okay, depending upon the pulses of the binary pulses to be transmitted, we are going to transfer the message in accordance with the pulse phases of that. Phases will be changed. The phases of the, okay, absolutely, the phases of this will be absolutely changed. Okay, the phases of the uh, phases of the carrier wave will get changed and it will be transmitted over this. That means the phases will get changed. That means what will happen, receiver? We will deduct the phases of the change and assume that, okay, there is one, there is a zero, there is a one, zero. Likewise, as the phases changes, it understands that. Because one will be coded is a PT into cos omega CT, and the PT, that is the information. If it is one, PT is equal to one, that is absolutely it consists of that. It will transfer into P of T to cos omega CT. Okay, and similarly, when you take the zero pulse, the minus pt into cos omega ctp, that is the difference, as detect the phases at the receiver, detect the phases changes and assume, and it will be formulate, that is the information maybe 1000 according to the phases. That is very important, the phase shift. So this is absolutely, I hope it is very clear now. Okay, this is all explanation given. Okay, see, look back, one important, we are the chosen, why we did not take OK, that is on off key, as I shown in ASK. See, that is all depends of the situation. If the information is so, if the information what you are going to choose, then depending upon that you can use that our any kind of the digital modulation with ASK and FSK. This is absolute. Each one will have advantage and disadvantage, which I am talking at earlier, later stage. Right now, understand ASK is the one, the amplitude of the carrier wave will pass whenever there is a one, whenever there is a binary input signal is a one, where I'm going to change the phases of the signal. Okay, exactly. The phases of the signal, phase of the signal as a change, and indicating that how that 1 and zeros will be changed. Absolutely. That is exactly we call it as the phase FSK model. And next, come back to the last one, what we call it as, okay, before taking phase shift, let us take power spectre. See, look back, the power spectre is very important because power spectre indicates the magnitude of the signal. The magnitude of the signal is depends upon energy of the signal. Energy of the signal gives the information. So here also, since only one carrier we are going to use it, that absolutely most of the carrier within, that means the information we are sending the binary sequence pulses through a carrier wave, which is clustered as around plus or minus omega c. That is where the spectral density is absolutely zero. Next, last part is exactly we call it the frequency shift key. Look back, let us say this is the information 10110001 here. This is the information you are going to send it across to that. This information, look back here. This information, okay, absolutely 1000 like this. Look back here. The frequency will be changed. Look back here. This is the one. The frequency is absolutely here. Look back here. Very important. Please note down. The frequency 1 is, let us say, omega 1, and frequency for 0 is omega 2. That means the frequency representing the, see, look back. Frequency is what exactly? Number of cycle per second. See, number of cycle per second used for transmitting the signal, binary sequence signal, that is, let us say pulse is 0, will have, let us, omega c, that number of signal per second is more. If you want to transfer one pulsar, the number of signal per second, that is a hertz, that is a frequency, is absolutely different than the what omega 1. So that means kind of a different frequency you are going to use for transmitting 0, for transmitting 1, we call frequency shift key modulation. That is shortly we call as FSK. Why we call it as shift here? This is the most important we talked about shift, because we change the carrier frequency, because we are going to very mentioned the modulation techniques, two important. One is baseband signal, the information. Second is absolutely the carrier wave. That carrier wave, which is unmodulated, that carrier wave will be used for transmitting the message 10 and 11000011 through this manner, and 111 is absolutely like this, 000 is like this. So different frequency, we shift the frequency of the carrier wave in a different omega c1 and omega c2 is like this. Okay, so this is the frequency shift key. Since look back here, the power spectral density of the frequency shift key, please mind it, in a frequency shift we are going to use the two frequency, one frequency for passing the binary pulses, that is 0, another frequency for passing the binary pulse 1. Okay, exactly this, it means that the frequency shift key will consist of two frequency, omega c naught and omega c1. That means it contains two frequencies and two pulses. Look back, this is for omega c1 and this is for omega c2. So that means the information of the phase shift, that is a binary signal, will be clustered around this as this point. Okay, so now let's come back exactly in the demodulators. See, this is what we're talking about it so far is exactly modulation. What kind of a modulation you used? In demodulation techniques, you are going to use. In demodulation is the one retrieve back the information at the receiver of whatever we received. So that is exactly called the demodulation. What kind of a demodulation process absolutely used in the digital communications? See, ASK can be used. We can look back. ASK can be demodulated coherently, that is synchronously. That means just taking one pulses and edit whether it is 1 or 0. Or otherwise, you can go also with the non-coherent method. You can send it across to two signals, one frequency for one signal called as M12 and another signal is called M22. Each signal will be deducted a separate part of the circuit we call it as non-coherent. In coherent, what exactly you are going to send? In coherent, you are going to send only one kind of a signal, okay, through which you are going to identify whether it is a 1, we call it as. Where exactly? Non-coherent method, please mind it. We are going to send two signals, one indicated for one frequency, that is, let me say, for one pulses, or otherwise for another signal MT2 for representing a 0, which will be analyzed separately in the electronic circuit we call it as envelope detector or non-coherent. Please mind it, especially in digital techniques, we wanted to use what you call it as coherent methods as less as possible, because it contains only one circle, only one signal, and only one kind of analysis method goes. But of course, it's quite complexity, where exactly that complexity can be reduced in non-coherent, because we are going to use a two signal for identification. One signal, that one frequency, that is, for example, let's take FSK, one frequency for 0, another frequency for what you call it as this. So look back, this is kind of, they use this. The ASK can be utilized for, that is amplitude shifting demodulator at the receiver. It may what you call coherently or non-coherently. And PSK, okay, exactly, the PSK modulator will be utilized is absolutely with respect to what? Both coherent and modulation. Look back in PSK, okay, look back. The PSK demod cannot use as non-coherent because the envelope is same for both unknown and IR. The ASK can use for coherent or non-coherent. Look at in what exactly this means. That is a very important point to be. Students really struggle over this, whether it's a coherent or non-coherent. See, look back, one signal will be used in phase shift. There is a connection between that. I cannot use the two. Here, the same frequency, just we change the phases. The frequency is number of cycles. The phases is a quite different. Angle is a quite different. Please make note. Where exactly FSK, we can use a two frequency, we can use it two way. Where exactly when you come back to the ASK, which have a two frequency, one for one frequency and 0 for no signal will be passed. That is why we exactly ASK can be utilized for coherent, non-coherent. Where FSK can be utilized for two coherent, two signals, because it contains two frequencies. Where exactly in PSK we cannot use non-coherent, because absolutely it's quite difficult, because we will not change the frequency of the carrier wave which is chosen for. That is why carrier waves are chosen for sending the information, the digital modulation techniques, and absolutely scores. Okay, so this is what today's brief. Tomorrow we are going to take, because what kind of a techniques exactly we are going to use for what you call it as what kind of a what kind of a techniques used in PSK, because ASK is not very much preferred, because because it gives only for on and off key, where exactly PSK and FSK are quite used absolutely in that. Tomorrow we'll take it off. First, a PSK demodulation techniques, and then we go for PSK FSK modulation. That's completion, but it's a big chapter and very good, very interesting. But analysis has to go in a mathematical analysis with electronic oriented thinking. Okay, absolutely. We'll meet tomorrow.